Students and friends, welcome to my YouTube channel. Today I am going to discuss the convection problem. So already we discussed there are two types of convection, natural convection and forced convection. Forced convection problems already we uploaded theorem, concept, everything. So how we'll know that this is the forced convection problem, this is the natural convection problem. So forced convection, if velocity will be given in this question, then this is the forced convection problem. And natural convection or free convection. Natural convection and free convection both are same name. So when velocity not given, this will be the free convection problem. So what is the free convection? If fluid motion is produced due to the change in density, the mode of heat transfer is known as free convection or natural convection. So these steps I wrote already. These steps you have to follow to solve the question. So already this formula and all will be there in the data book. So what are the steps to solve the free convection problem? So first, as usual, like forced convections, what we are doing, film temperature we are finding. So film temperature here also will, film temperature Tf equal to Tw plus T infinity by 2. Tw is nothing but surface temperature. This is the fluid temperature with 2. Now with the fluid temperature, now with the film temperature, will from the data book we'll see the properties of the R, that is called density, thermal conductivity, kinematic viscosity, Prandtl number, all those things value will take from the data book, HMT data book. Then we'll find the coefficient of thermal expansion. This coefficient of thermal expansion will find only in the free convection problem only. Forced convection, this term will not be there. So how we'll find beta, that is symbol is beta, coefficient of thermal expansion 1 by Tf, that is called film temperature. That film temperature should be in Kelvin. So suppose here degree centigrade you will get. So we'll multiply 273, we'll get the Kelvin and find the beta, that is called coefficient of thermal expansion. Then we'll find the Grashof number, which formula will be G beta L cube delta T by kinematic viscosity whole square. This value will be there in the HMT data book, this formula. Then all the values will substitute G 9.81 beta, already this coefficient of thermal expansions will get, length will be given, change in temperature T, surface temperature minus fluid temperature, and kinetic viscosity, this value will take from the data book, will substitute. Then we'll find the status of the fluid. Status of the fluid, how we'll find? Grashof number and Prandtl number. If less than 10 power 9, that will be the laminar flow. Status will be the laminar flow. Laminar flow will be smooth, flow will be the straight line. GRPR, again we'll see what is Grashof number Prandtl number. If greater than 10 power 9, that will be the turbulent flow. If we'll decide, if the given data either less than 10 power 9 or greater than 10 power 9, according to this we'll see the laminar or turbulent flow. Based on this formula we'll select. For suppose laminar flow, this is the Nusselt number, 0.59 GRPR power 2.5. 0.25. So this is the laminar flow Nusselt number. If will be the turbulent flow, what will the Nusselt number? 0.10, Grashof number, Prandtl number power 0.333. So this is the Nusselt number we'll find. Once we'll find the Nusselt number, we'll substitute here HL by K. H is heat transfer coefficient, L is length, K is thermal conductivity. So we'll find here H, heat transfer coefficient. Once we'll find the heat transfer coefficient, then we will find the Q is equal to heat transfer for the vertical plate. Horizontal plate separately concept will give and problem will solve. This will solve first heat transfer for vertical flow, vertical plate. So vertical plate Q is equal to what is HATW minus T infinity. So always convection problem once you are finding, we are finding the heat transfer means only H will be the unknown. So H will get from the Nusselt number and we'll find the heat transfer rate. So this is the concept, this is the steps, simple steps to solve the questions. Now I taken one problem, free convection problem, or you have to decide what type of problem, we'll see. So a vertical plate of 0.75 meter height is this much surface temperature and exposed to the air at temperature, this is called fluid temperature, and 1 atmosphere. They are asking calculate mean heat transfer coefficient, that means they are asking that H, and rate of heat transfer Q, they are asking rate of heat transfer HA TW minus T infinity. So once we will find the H, Q also can find out. So okay, per unit width, that means width they given 1 meter. and length they given 0.75. So area we can find out length into breadth. Okay. So this is the problems given. So now here velocity they not mention. They not mention the velocity. Solutions if we'll solve this week, we'll write velocity not given. Velocity not given. So this is free convection problem. This is the free convection problem. So what are the steps we'll follow now? First we'll go the film temperature. Directly we'll write notations already there. Film temperature TF will be TW surface temperature plus fluid temperature by 2. So they given 170 plus 105 by 2. So it is coming 137.5 degrees Celsius. They are getting 137.5 degrees Celsius. Now, if like this value is coming 130 to 132, 33, 34, 37 like data book you will see now 120, 110, 130, 140 like this value will be there. So what we'll do, we'll approximate it because this is more than 135. So we'll approximate 140 degrees Celsius. So our film temperature will be 140 degrees Celsius. Why we approximated this? Because in HMT data book, once we'll find the properties of the air like kinematic viscosity, thermal conductivity, Prandtl number, density, we'll see from the 140 degrees Celsius. Because data book like this, they give a whole number 130, 140, 120 like this. So fractions value will approximate near value. So from the HMT data book, we'll write all the value. Density how much is there? We'll see from the table 0.854. 0.854 unit kg per meter cube. Then if you'll see the Prandtl number will be given 0.684. 0.684. Then thermal conductivity given 0.03489. 0.03489 watt meter Kelvin. This will be there in the page number approximately 42, 43 according to the which editions data book you have. So around 42, 43 page number, this all the property will be there. Then kinetic viscosity also will write. Kinetic viscosity will be 27.80 into 10 power minus 6 meter square per second. These are the kinematic viscosity. This approximately page number 42, 43, 45 like this according to the addition, this value will be there. So what I did, we'll find the film temperature, we approximated, then we wrote the properties. Once we wrote the property, then we'll check the status of the fluid. Before this beta we need, so coefficient of thermal expansions we need. So beta is equal to 1 by TF. That should be in Kelvin. So 1 by what is this value? This will take not approximate value. We'll take 137.5 plus 273. So it becomes Kelvin. So if we'll solve 1 by this, if we'll solve now, this value is coming 2.4 into 10 power minus 3 Kelvin. So it will come per Kelvin. So this beta value I know. Once beta value I know, then we'll go the Grashof number for the vertical plate because they given vertical fluid. So Grashof number for the vertical plate. So GR is equal to, while writing formula, G beta length power Q, then change in temperature by kinematic viscosity whole square. G nothing but 9.81 will take. Beta value we got here. This is the beta value. 2.4 into 10 power minus 3, the length 0.75 power cube, and then temperature difference 170 minus 105 divide by kinematic viscosity 27.80 into 10 power minus 6 will be the whole square. So you will get the Grashof number here. So we'll check the value one more time. G minus cubes, okay. So square. So it is value is coming 8.35 into 10 power 8. 8.35 into 10 power 8. Now we'll find the status of fluid. So before this we need product of this. So GR PR product I need. So GR PR if you product na this 8.35 into 10 power 8 into GR PR value 0.684. If you'll find this value is coming 5.71 into 10 power 8. I think so. I'll check it. 5 point. Which value I told? GRPR value. GRPR value will be 5.71 into 10 power 8. Correct. So this is the value we got. Now once you know this value, then this status will find. This value is what is? Less than 10 power 9. 5.10 power 8 here. So this is the laminar. So this we can say this is less than 10 power 9. So flow is laminar. Then laminar flow, what is Nusselt number? This is the Nusselt number. For laminar flow, Nusselt number will be 0.59, Grashof number, Prandtl number, power 0.25. This will be there also in the data book. This will be the data book. Approximately page number you will see 144, 143, 142. Page number will be there according to the edition of the HMT data book. Now if we'll substitute here all the value, 59, what is GRPR product? We got 5.71 into 10 power 8. Then power will be 0.25. So this value is coming, Nusselt number value is coming 91.21. This value is coming 91.21. So this is Nusselt number. Again Nusselt number will be formula what is? HL by K. HL by K. So that implies Nusselt number will be this 91.21 is equal to H into 0.75. This value will write here 91.21. So rub it here. 75 by K. K value is there here 0.03489. If we'll solve there, H value will come here. H value will come 4.24. 4.24. This unit will be watt meter square Kelvin because heat transfer coefficient. Now once you know the H, they are asking mean heat transfer coefficient. So one answer is over. One answer. This is one answer. Now heat transfer na Q. Q is equal to formula either HA TW minus T infinity, surface temperature, fluid temperature. If you write the H value 4.24 into area 1 into 0.75 per unit width they given and length is 0.75. Then 170 minus 105. So this value will come somewhat. This value will come 206.8. So Q is equal to 206.8 watts. So this they are asking heat transfer rate per unit width. So this is the solutions for that question. So steps you see here again one more time. So what we did first, film temperature we find it. Film temperature we got 137. So already told if this value is 134.5 now we'll go 130. 135 plus now 140. So near will approximate because data book degree will be there like a 140, 130, 60, 50 like this only. Okay. So from the HMT data book, we'll see all the properties like thermal conductivity, density, Prandtl number, kinetic viscosity. We'll take. Then we'll find for free convections, this we have to find out the coefficient of thermal expansion. So 1 by TF in Kelvin. So we got it. Then Grashof number value already we substituted, and we got this is Grashof number. Then we find this product, and we'll see the status of the fluid, either laminar or turbulent. So this given problems is laminar flow. So we taken the Nusselt number for the laminar flow and substituted the value. We got the heat transfer coefficient. That heat transfer coefficient we substituted here, and we got the heat transfer. Okay. So this is the solutions for that questions. Okay. So okay, students, watch this video carefully. These steps you watch. Try to remember these steps. Then based on this step, you can solve these questions. Okay. So share this video to your friends so they can also get the benefit, and subscribe the channels. Okay. Thank you.